So if you're getting into web development with Rust, I'm willing to bet you've asked this exact question. It kind of feels like you're supposed to pick a winner out of these three, right? But what if that's completely the wrong way to look at it?
And that, right there, is the big secret. These aren't three libraries fighting for the same spot in your project. Nope. They're actually carefully designed layers in a stack, and each one has a very specific job to do. Getting this one concept right is basically the key to unlocking the entire Rust web ecosystem.
So, let's get into it. We are going to pull back the curtain and really demystify the Rust web stack, one piece, one layer at a time. Okay, so here's the plan. We'll start by looking at this puzzle itself, and then we're going to build the stack from the ground up. After that, we'll zoom out to see the full architecture and even compare it to some other ecosystems you might already know. And finally, we'll dig into why Rust does things this way in the first place. All right, let's tackle that initial confusion head-on. The goal here is to transform that feeling of, whoa, there are way too many pieces, into a really clear picture of how this incredibly powerful modular system all fits together.
To really get it, we need to build our mental model from the absolute foundation, from the bottom up. So let's start with the engine that makes everything else go.
Meet Tokio. This is the bedrock. Seriously, if you're doing anything asynchronous in Rust, handling lots of things at once without getting stuck waiting for one to finish, you are using Tokio. It's the fundamental runtime that schedules and executes all those async operations. To put it simply, without Tokio, nothing else we're about to talk about can even run. This is just the perfect way to think about it, right? Just like an OS manages all your computer's resources, Tokio manages all your program's asynchronous tasks. It makes sure everything runs efficiently and doesn't get gridlocked. It's the boss of your program's concurrency. Okay, let's move one layer up the stack. This is Tower, and it's built on this one core, incredibly powerful idea: everything is a service. Now, a service is just something that takes a request and gives you back a response. That's it. And this simple idea is what lets you build things like logging, or authentication, or rate limiting, as these totally modular, reusable components. And this Lego analogy, it is spot on. Each piece of middleware you add is a block. You stack them, you rearrange them, and this is the really crucial part, you can use these same blocks in totally different contexts, not just for web servers. Now we finally get to the part that you'll actually interact with the most: Axum. This is your web framework. It gives you all the friendly, high-level tools you need to build your API. Defining your routes like /users, parsing JSON from a request body, and sending back a response. It's built from the ground up to work perfectly with Tokio and Tower. And the best part is, you don't have to build all those Lego blocks yourself. Tower HTTP is a crate that's basically a whole box of common pre-built middleware. Need to handle CORS or compress your responses? You just grab the right piece from here and plug it directly into your Axum application. It's literally like a plugin pack for Tower. So let's put it all together. A request comes in from the network, right? Tokio, our runtime, picks it up. Then it flows up through your Tower middleware layers, your logging, your auth, whatever. And finally, it hits your Axum application logic. That right there, that's the core stack. But hold on, that's just the application itself. To really understand a real-world deployment, we've got to zoom out a bit and see all the other critical components that surround our app. And here we find another crucial piece of the puzzle. See, Axum defines what to do with a request, but it doesn't actually get that request from the network. That's the job of an HTTP server like Hyper. Hyper is the low-level piece that's actually listening on a port, accepting connections, and parsing the raw HTTP. And of course, to build a complete application, you'll pull in a few other key players. You've got Hyper as your HTTP server. You'll almost certainly use Serde, which is the go-to library for handling JSON. You'll connect to a database with a tool like SQLX or Diesel. And then in production, you'll probably put a reverse proxy like Nginx in front of the whole thing. Okay, I get it. This might feel like a lot of different pieces, especially if you're coming from other ecosystems. So let's try to translate this Rust-specific stack into a language that might be a little more familiar. Well, the core difference really comes down to philosophy. The Node.js world often prefers a bundled approach, where one package, like Express, does a whole bunch of jobs at once. Rust, on the other hand, strongly favors a composable design, where small, really focused libraries are put together like building blocks. This table is a fantastic Rosetta Stone for this. Look, Tokio is basically your Node.js runtime.
Hyper is like the hidden HTTP module that's already inside Node. Tower is the Express middleware pattern, and Axum is the Express framework itself. It's all the same concepts, they're just broken apart into more explicit, separate pieces. But here is where the two paths really diverge. Both have an event loop, check. Both use async await, check. But then look at the bottom. Node.js is famously single-threaded. Tokio, on the other hand, is multi-threaded right out of the box. And this is an absolute game changer. It means your Rust application can automatically use every single CPU core you give it, which gives you true parallelism without all the headaches.
So that brings us to the final, and I think most important question, why? Why does Rust do it this way? Why have all these separate pieces? Well, this is where the genius of the whole design really starts to shine.
This modularity gives you some incredible benefits. You get flexibility. If a better HTTP parser than Hyper comes along tomorrow, you can just swap it in. You get amazing performance because each library focuses on doing just one thing and doing it exceptionally well. And crucially, you get composability. Axum doesn't need to reinvent its own middleware system because it just reuses Towers, which is shared infrastructure across the entire Rust ecosystem.
And that all leads to this, the ultimate payoff. This is what the modular design gives you in the end. The easy, event-driven programming style of Node.js, the massive multi-threaded scalability of Java, and the bare metal, no compromises performance of C++. You really get the best of all worlds, all combined into one stack.
So, in the end, it's a trade-off, right? The Rust ecosystem asks you to assemble a few more pieces yourself up front, but in return, it gives you incredible flexibility, raw performance, and long-term reusability. Which, of course, leads to the big question. Is this highly composable, performance-first architecture the future of web development?